3D Printing Today, show number 385. Better belts. How the Chinese won. 3D sets.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, doesn't matter. We cover it all. My name's Andy Cohen, and I'm here with Mr. Whitney Potter.
How you doing, Andy?
I'm doing pretty good. It's so nice to have you back here again.
It is.
It's going to be a while.
Back.
It's going to be a while before I get used to not having the hustle of doing it remotely online.
Oh, God, that was a pain.
Oh, yeah.
And it really affected the production quality, too.
It did. It affected our audio quality. It affected how much work it was.
Yeah.
That said,
and we can't just talk when we're on
that said,
on Skype.
I'm looking at a new form of distribution of the podcast, using an app called Headliner. Now, I'll talk more about this on our outro on the other end. But in the meantime, we do have a story this week that I wanted to talk about, and that's about a story that came out that was on one of the, I think it was 3D Printing Industry. And it talks about a position paper that was published by an organization called the ECTA. Do you remember what that stands for?
That's the European Communities Trademark Association.
Now, this white paper is basically saying, hey, 3D printing's changed things, so we have to change our intellectual property rules. And they took a couple of positions in there, and I want to review them. And if you're out there and you're familiar with this paper, and if we get it wrong, I hope you'll contact us and correct us, because I've skimmed the paper, and there are things in there that I got to admit I don't fully get. But in a nutshell, what it seems to me is it's a couple of things. One thing is they want to tie the protections to the digital representations, be they CAD files or STL files, or some digital representation, and not necessarily a physical design, a physical thing. Now, this first item we're a little puzzled about, because we always thought that protection includes your drawings, your models, your products, and I would have thought the CAD files were already part of that.
Yeah, I would have thought that a CAD file would be subject to copyright, but that's kind of irrelevant, because if you're talking about, if we're talking about making a widget, right, then, if you have the original CAD file from the original, the OEM CAD file, and you 3D print that, then you're making an exact copy of it. But on the other hand, if the original part wasn't 3D printed, then maybe the CAD file, even having the original file will not be appropriate for 3D printing. So that's not necessarily a cut and dried thing. You might need to modify it to make it work, in a 3D printed form. But the question is are you copywriting, or are you, placing intellectual property protection on the actual file, or are you placing that protection on the part, on the functionality of the part?
I think the protection's going to the file, and the way I read this was more, and although they didn't mention this in the article, I looked for it. It's more protection for virtual kinds of things. Let's say you've designed a VR game, and all of your designs are virtual and they're not real. By adding this protection, one could not pull the virtual versions out and 3D
create
print
minifigs.
them. Make fakes out of them.
Yeah.
But that's only the first part, and that part was not that big of a deal. It was the next part which I kind of went, whoa, no, I don't agree with that, and that's spare parts. Currently, the EU has protection on spare part design for only 5 years. Now, I did not know that. I was unaware of that. So if let's say you're in Germany and you design washing machines, and you have designed a specific valve part, and that valve part is not as reliable as you thought it was, or it's a part that is going to wear out. So you manufactured a warehouse full of replacements. your design on those replacements is only protected for 5 years, and after 5 years, anybody can take that design, an old valve, and redesign it themselves, reverse design it.
But in what respect is that design protected? Is that valve patented? Is there a copyright on the drawings to make it? I'm not clear what the exact.
Well, remember,
protection
we're
is.
talking EU,
Right.
but the way I kind of read it was that they're protected, and they could sue those who've made the designs within the 5 years for license infringement. They could say, hey, that should cost you $50 per part that you've produced. I'm just kind of shooting from the hip on
sure,
that.
yeah.
But in the paper, they're saying they want that extended to 10 years.
Uh-huh.
Now,
Well, of course they want it because I mean this is a position paper written by an association of people that hold all the patents or hold all the designs. So they want it protected.
I'm going to knee jerk on this one because the way things are built. I mean, when was the last time you bought a refrigerator?
Oh, about 10 years ago.
Refrigerators are quickly becoming disposable items like
sure.
TV sets.
Yeah.
And they're being made to fail within 5 years, 5 to 10 years.
Well, they're not serviceable.
Yeah.
I learned that much on it from we had a service. I actually had a service call on the refrigerator because there was a little water filler thing in it that just didn't work. And the guy went in and opened it up, and it was just a loose wiring harness, just a connector that needed to be plugged in, and everything worked fine after that.
Yeah, but I'm talking about structural things that can't be fixed.
Yeah.
And that really drives me crazy because the way designs are going, because of it's not just because they want it to be to sell you new ones. Mm-hmm. It's also because their design methodologies and their task flows are so much more efficient, and so fast now. And just like your iPhone, they're going to come out with a new one and a better one and a better one and a better one. So they put in this design obsolescence into it. Uh-huh. It doesn't make sense to make the protection on spare parts longer. It makes sense to make the protection on spare parts shorter. So instead of 5 years, it should be 2 or 3 years.
I mean, to encourage the other people in the industry to produce spare parts for these things.
Not only that, but it should be the EU should be actively encouraging the decentralization of spare parts production to minimize overproduction. Mm-hmm. Doesn't make sense to have one big factory generate 3 million spare parts and put them in a warehouse for 10 years. That doesn't make sense.
Well, in 10 years, nobody's going to want those spare parts.
Yeah, that's exactly true because the designed obsolescence.
Right. In 10 years, you're going to have to find those parts on eBay.
Yeah. So we don't agree with this position paper. Our position's different.
Our position is different. We should write our own position paper and send it to the EU.
Yeah, we should. We definitely should. Well, I can guarantee you there's a lot of 3D printing related people in the EU that are taking their position on this position paper. I know the position I'd like to put this position paper
right. But instead, we should probably just do a show.
So what's coming up on the show this week?
We start out talking about better belts, talking about replacement parts, right?
Yeah, right. Then we're going to discuss how we feel the Chinese have already won the 3D printer competition.
And then you'll give us a look at 3D sets.
Let's do it. So you heard us talking a little while ago about the quality of the bottom of an object printed off of a belt printer. Both the iFactory one and the Cumming CR30, also known as the print mill from Creality, use a cloth-like material in their belts. And they have a weaving pattern. And it's that pattern that creates the physical bond or the physical mechanical kind of bond that holds the object to the belt, the way blue tape used to hold objects to hard plates. And right now, I just don't see a way around that. Do you?
Well, I have been thinking about it since we've been talking about the world of belt printers. It seems like the belt itself is kind of the limiting factor in that whole design right now. So I started thinking about, different things we could do, different ways to do it. And I was thinking, I have a roll of a material in my shop called tool wrap. Now, we use this in metallurgy when you're heat treating a part and you don't want the part to oxidize. So this is basically stainless steel foil. It's heavier than regular tin foil. But it's stainless steel, so you can wrap a part up with it, put it in a furnace. Like if I'm making Damascus steel, right, I can't have oxygen getting in because it oxidizes the surfaces and the parts won't weld together, the layers won't weld. So what I do is stack my metals up, wrap them in a piece of paper, then wrap it all in the tool wrap. The piece of paper burns off and scavenges all the oxygen inside, and then the tool wrap, keeps it sealed, right? So that's what it's designed for. You can get it from any industrial supply. It's not terribly expensive. I mean, it's, I think, about $100, $150 for a roll of it, which is, the roll is kind of a lifetime supply for me. But it is super, super thin. It's kind of like, if you imagine like kind of the heaviest weight aluminum foil you can get, and then probably double that. So you can cut it with scissors, but it is very tough, durable stuff. You have to be very careful with it because the edges of it are absolutely razor sharp. So you do need to exercise some caution with it. But thinking about using that as sort of a substrate for a belt, right? Then it's just kind of a matter of how do you splice it together.
Right. That's the big question.
Right. Well, I've been thinking about sort of the different materials we've used, for printing surfaces. Kapton tape is quite readily available in almost any width you can imagine. So what if you use kind of a sandwich of stainless steel tool wrap and then put Kapton tape over that? And just staggered the splices. So, the splices were, happened on opposite sides of the belt. The adhesive on the Kapton would basically hold the tool wrap together, but the tool wrap would give it some body and some, rigidity to it. Or even you can get adhesive coated PEI sheet as well, or adhesive film, I guess. Just kind of thinking about possible ways we could make better belts because, I'd really like a smooth belt that either works, by itself because of, the material, or that you could add, like a liquid vinyl spray to, like we're accustomed to doing with our rigid glass plates. So, anyways, just stuff I've been mulling over. Thinking about doing a conversion of Gigantor to an enormous belt printer, just for the fun of it when I have some time. The design of Gigantor is such that it would be very easy for me to just take the XY axis off and turn it 45 degrees. That would just be a matter of unscrewing some bolts and figuring out a new way to attach it, because the XY is one unit that's removable. I designed it like that so I could upgrade it. Didn't occur to me at the time that I could turn it into a belt printer that way. But then I just got to build the belt.
Well, if I recall, the White Knight that I saw at the 2019 Murph had a steel belt. And I remember talking to the fellow who built it. I forget his name. A really nice fellow. I apologize for forgetting your name. I think his name is Kurt. And he told me that they actually customize automobiles. So you can imagine how awesome the White Knights that they had there looked. They were gorgeous. I thought they were possibly the most interesting printer there, except for possibly the Tool Changer. It was a great year for Murph, and I can't wait to go back. But I recall talking with them about it, and they told me that actually the hardest part of the White Knight was sourcing the belt. Not necessarily attaching it. They seem to get that worked out fine, but getting the belts themselves. Now I would expect that the real issue here is not technical or engineering. It's supply chain, and is it worth it for those who produce it to actually make it? And it's really as we've seen in the past, it's a function of how many people are going to buy it, how many people need it. Right now, not very many people, But if you could figure out how to make a belt to replace the belts that come on the iFactory 1, as well as the belts that are on the CR30, and sell them direct, then you'd have customers. So maybe in the future, if these printers catch on and they sell enough of them, we'll see improvements in the belt. That's a big maybe, because these are not really low-budget printers, unfortunately. The iFactory 1 and the CR30 are both aimed around $1,000, and that's out of the realm of, Ender 3, CR6, ANET 8. No, that's out of that realm, even though it does seem to satisfy a lot more use cases than we were led to believe originally. It's much more useful, much more capable than we thought it would be. Even though that's the case, it may not sell that many as compared to those other machines, which would not give us enough market draw, enough motivation. So we'll see.
But if you think about it, other than the belt itself, mechanically, there's really nothing more to it. You've got, 3 axes of motion, whether you're, twisting the roller on a conveyor belt or whether you're moving a linear axis. Mechanically, those are quite comparable in terms of the complexity. In fact, you could argue that the complexity of the conveyor belt is actually simpler than making a linear guide system. We're just so accustomed to linear guide systems that we think we think nothing of them because we can just buy one off the shelf and implement it. But there's a lot of complexity in that, compared to making a belt on rollers where you're just really just dealing with a couple of bearings and a little bit of mechanical stuff to get the alignment and the tracking done.
There was some fear originally that they wouldn't be accurate enough. And to be honest with you, I'm not getting consistency as much as I would like to ensure tolerances are met for every print. For example, when I printed walls of the Nocturne Alley Book Nook, they came out beautifully, absolutely gorgeous detail, but one part was longer than the other part, and that part's length was determined by the movement of the layers on the belt, which means the belt itself, while it looks nice and clean, it was missing, and it piled up in the layers. So there was more, layers were thicker than they should have been. I can't see it visually, but at the end, I'm 3 millimeters longer, and it does add up over time. So it's not perfect. And I look at the belts. The belts are made of these materials, and the materials are made for conveyors, industrial conveyors. And I wonder, they're under extreme tension, probably more tension than they were originally designed for, because it has to be perfectly flat for it to work well, which means you've got to make the belt on both of these machines very, very tight. And I wonder, what happens over time? It's a polymer, and any polymer, soft polymer, will stretch. It will move. So I'm thinking, and I'm raising the question to a lot of the other folks out there who have these machines, are you seeing any stretching? And so far, I'm not. But I could tell you for sure, when this machine's in the garage and stored in between prints, I'm going to be popping off that rod that tensions it. When it's not in use, it will not be under tension. And this design in the iFactory 1 allows for popping that rod in and then it's all set, versus the CR30 where it's all screws and you have to adjust it. So from that perspective, the iFactory 1 has an advantage. And I suspect you can't keep it under tension permanently.
Well, conveyor belt material is typically fiber reinforced. So there's probably some either some polyester fiber or some nylon or maybe fiberglass that's actually embedded in the material as the material is being fabricated that helps keep it from stretching. Every conveyor belt material I ever worked with was very, very, very tough, but definitely after it stretches in, it shouldn't stretch any further, because stretch is a problem for any conveyor belt application. That, if it stretches too much, then you don't get enough friction on your drive roller, and it doesn't work.
Right.
So
we'll see over time.
So while we were recording just now, I got a reminder about a streaming Zoom meeting about the Plybot that I was invited to by Ian Wilder or Wilding, I forget his last name, the fellow who's kind of leading up the Plybot. And I while we were recording, I stopped the recording and we went and took a look. And it's this huge pile of people's faces, a huge pile of talking heads. And in one of the tiles was Brook Drum with a Plybot printing. And it looked cool. It did look really cool. I mean, the idea of these two moving arms that go up in Z was pretty nifty. It was slick. It was very nifty. But
it has kind of the quality of a Delta printer, in that you kind of look at it and go, how does it possibly get all of the places it needs to, because the mathematics of how it works is not entirely you have to take a minute and look at it and think, just how is that going to work? But it's cool. It's cool to look at,
Yeah, but it made me wonder. No, we immediately left the Zoom meeting so that we can continue recording, not because we didn't want to take part. But I looked at it and, it looked cool, looked neat, looks like it prints really well. But there's two things. One is it's not doing anything that we can't already do. It's not printing at really high speed. It looks like it's printing at the same speeds that the typical Mendel-based machines print at, such as the Ender 3 and the Prusa i3. I don't see an added value. I don't see anything that differentiates it. It's not doing multi-materials. It doesn't have an infinite Z. I mean, there's nothing there that says you could do way more use cases if you get this machine. So there's nothing there that differentiates it technically beyond that it's a new toolpath kinematic approach, and it looks really nice. But there was a second issue, which I think is more relevant, and it kind of highlights how the Chinese won this market, how they basically took it away from first the American market, which dominated it back in, 2011? How long ago was that?
It's been a while.
2010 to 2012, I think, during the replicator time.
The cupcake days.
It took it away from Ultimaker. And while Prusa's holding on, it's basically built its market base rather than taking other market. So you still have Prusa selling really well compared to what it's always sold, but compared to what the Chinese sell, I don't think Prusa's doing it nearly as well. I mean, we're hearing units in the millions with the Chinese makers. And when looking at the Plybot, I think it highlights that what it is that the Chinese did that really made the difference. And it's not that the Chinese used the open source designs. Anybody could use the open source designs. What I think the Chinese did that they figured out that's the most valuable aspect that made them win their war, besides the fact that they also have a very close relationship to the components themselves, which are made in the same location, possibly by the very same people. They figured out how to assemble a printer easily and packing it flat, so they can sell a lot of them and ship them super cheap.
Right. You got to remember, we live in a flat pack world, right? I mean, what is the world's most popular furniture store? IKEA. Why? Because everything they sell is flat. It doesn't make sense to ship air, so everything's got to pack flat.
Right. So if you want to purchase a CME CNC Boss Delta, you're going to be paying a lot in shipping. I know because the guys I work with at the company I consult to just got one. It was a ready-to-print machine, not a kit, and it came in a huge crate. When we got our Race 3D N2 years ago, it had to be shipped, and it came in a huge box. I could barely get it into the back of my truck to get it home. The Plybot is going to have to go in a big box. There's no way around it. And that complication in shipping affects quantity. You're not going to be able to do the throughput that, say, Creality does with the Ender 3 or the CR10, especially the CR10. The CR10 goes in this flat box. My Predator came in a flat box. I couldn't believe the size of the box for such a huge printer. Why? Because they broke it down into really easy to assemble components that keyed and aligned themselves as I bolted them together. So it's a combination of packaging and designing the semi-assembly requirements in such a way so that the result is successful and effective. That's where their genius is. That's where they've won this market over. And unfortunately, without some significant differentiation, the Plybot will not be able to compete with that, in my opinion. But time will tell. We will see.
It seems to me that it could be made flat pack because it's basically got a lead screw and two linear guides that attach to the base, right? And that all could come off. The arms would be assembled as one unit, and you just slide them on and plug it in. But it's always going to be some assembly required there. Yeah.
If you take a good look at the Plybot, to me. And those listening, if I'm wrong, please email us and tell us, and we'll go back and revisit this. But to me, it looks like Brook Drum brought in the manufacturer that did the Metal Simple in the later iterations. It looks like bent sheet metal that's been powder coated and spot welded. And I don't see how the rectangular area that comes up off the bed that raises up, that has the lead screw and the arms coming out of it, I don't see a way to disconnect that to break it down. I don't see that.
Well, you can see they have a parts breakdown view of it, and you can see that sheet would come off the back with some, there's probably half a dozen screws or something. I don't know that it's designed to do that. It's kind of hard to tell from their exploded parts drawing, but it's a separate part. It looks like there's things attached to it, which would suggest that it's not really designed to come off like that. But I couldn't say.
Oh well, too bad we couldn't sit in the Zoom meeting. Maybe they would have answered some of that. I had no idea that they were doing it while we were recording. And I think our podcast has precedence, in my opinion. So let's see. We've done segments on 3 companies so far that have based their business model on home 3D printing. The first company, which is probably the oldest one, was a guy who goes by the artist name of Dizengoff, and his website is 3dizengoff.com. And he's basically a kind of a math artist who does amazing sculptures that really can only be 3D printed in one form or another. And he's been around for quite a while. And then the next one we talked about was this company that makes RC airplane models. And you can, and what they do is they break the models down so that you can print the parts on a relatively small machine, such as the Ender 3 or a Prusa i3. And then they fit together neatly, making a very durable, super light structure, which is pretty easy to fly, and they've got lots of models. So their entire business model, like Dizengoff, is based on having a 3D printer at home or accessible to you so that you can make the actual product. And then we did a third one from a fellow in South Korea called Fab 365. Now, this individual, I got to say, is one of the most brilliant designers I've ever seen. The products are basically toys, toy cars, toy rocket ships, and they fold together. Just lately, I got an email from him about a sale that they were having, but it really was kind of a trick to get me to look at the new models he had. And he just put on the market a model of the Caterham Super 7, one of my favorite cars ever made. And his design of his model is, I mean, that's design genius. If you're fascinated by people who make brilliant designs, go look at the Caterham Super 7 on the Fab 365 website. I just purchased it, and I'm in the middle of printing it and building it. And it's coming out brilliantly, and wow. So I thought, while Whitney and I are here in real time, let's see if we can find another company, probably hobby-based, that has based their entire business model around the assumption that you have a 3D printer and you're going to 3D print all of the critical parts for this hobby. So the first one we looked at was for rocketry, and I didn't find anything that was really a company that sells rockets that have to be 3D printed. We did find Apogee.com, and on Apogee.com, which sells rocket stuff, we saw an article by someone who I'm pretty sure we know from online, a guy named Gary Crowell, and he's been doing some awesome stuff. But he doesn't sell the files. It's not a company built around it. Maybe it could be, Gary, if you're listening. But so then we went back again and we did a search on RC cars, and I'm sure there's more, but we found one that had to slam on the brakes, and that was a good joke. Slam on the brakes and take a good hard look at it. And if you're interested in four-wheel drive RC vehicles, check out 3dsets.com, 3dsets, 3dsets.com. They've, again, a company that's built its entire business model around the assumption that you're going to 3D print essentially the product. They sell you the digital files. And they have 3 models of 4-wheel vehicles, one that looks like a Jeep, the one that looks like a Land Rover. Interestingly, Whitney pointed out to me that they don't actually use the actual names of the cars, probably because there's copy infringement kind of stuff.
Yeah, Jeep is very active in licensing their name to put it on just about anything. So I think they're smart to avoid using the J word, but it looks just like one.
Yeah, it looks like a Land Rover and either a Land Cruiser or kind of a custom Bronco kind of a thing. It does look kind of like a Ford Bronco. What's really interesting is that the photographs they took, the vehicles look like real vehicles. They don't look like models. The detail is so high. The quality of the 3D print is such good quality. I mean, maybe they're cheating. Maybe that is a real vehicle.
You can see the layer lines if you look closely, but they're not really apparent.
Well, not in the photographs I'm seeing right now. I don't know. I think that's a real vehicle. I don't think that's a 3D print. Anyway, in their video, though, they do show the assembly of one of the Jeep derivatives, the Rancher 4x4. There's a video guide. You can see it building. And according to what we're seeing on there, you do have to purchase the springs and the shocks, the tires, and the RC gear. Other than that, you 3D print everything, including the suspension parts and the gearing, the transmission parts, which should be interesting. Now, things are not super cheap here. I mean, for the fellow at Fab 365, it was like, $4, $2. Here it's about $40 for the digital files.
But this is much, much more involved because, I mean, you are actually, looking at the details on here, you are printing the gearbox, you're printing all the gears and then setting them up with ball bearings in the gearbox, and you're printing universal joints and suspension, and, it's built like an actual Jeep. Or a Land Rover in that case, but it is you are 3D printing all of those parts. So this is a monster-sized 3D printing job.
Now, for those of you out there who have dabbled in RC cars, as I have, I have a host of them on above my credenza because I used to get one every year from Radio Shack because I used to own a Radio Shack. And we used to sell these things. And the ones we used to sell were toys. They were not hobby-level machines. Now, I've also had hobby-level RC cars, such as high-speed racers that I used to race in Ontario, California, back when I was down south. I still have all those cars, all those parts. And we're talking pretty expensive. As I recall, and this was about 25 years ago, the kit was about $500. And every time I raced it, all the transmission parts had to be replaced. And if I crashed it, yeah, you kind of cough up money to replace the parts that you broke.
So you were basically in the NASCAR of RC car racing.
Yeah,
right?
Back then I think that was the case. I don't know if that company is still there down in Ontario, but yeah, it was crazy. I mean, these kind of cars go so fast that if there's any dirt, like a tiny pebble on the road that they're driving on, that it lifts them up and the wind force sends them into the air. That's how fast they're going. Now, in this case with, 3D sets models, you're not going that fast. But the point is since you've 3D printed the entire thing, something breaks, turn on the printer. And you replace the part.
Sure. And the best thing is, the rule about four-wheeling is you have to get home at the end of the day, right?
Yeah.
And with these, if you really get stuck, get high-centered on something that you just cannot get off of, the hand of God just comes in and picks the whole thing up.
Yeah. Anyway, I'm really impressed. 3dsets.com. Our fourth in our search for hobby companies and just companies in general, which are based around home 3D printing. If you know of one that we haven't found yet, please don't wait. Give us an email. Send an email to us with the reference, and we would love to feature that company on our show.
Yeah, what I think is really cool about this company is that not only are they sort of sell the stock model, but then they also have different ways to accessorize, because that's sort of one of the big things of full size 4x4, that as a hobby is customizing and accessorizing your vehicle. But you can spend thousands and thousands of dollars doing that, whereas you can get some of the same experience of doing that on a little RC model. Customize it, trick it out, put, bigger rims. You could 3D print an absurdly high lift kit.
For sure, this will keep you busy in the pandemic.
You bet.
Hey, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed. To all of our very supportive listeners, hey, thank you out there for all of your support on Patreon and the positive reviews. We really appreciate that. We do it for you. We do it for fun. There's still no ads on this show, even though our numbers are making the advertisers knock on our door. And speaking of those numbers, so I mentioned in the intro about an app that I'm using called Headliner. Headliner takes our podcast, which we've already published. It only do it to already published podcasts. You can't do it ahead of time. And it re-encodes the podcast into a video file. In the process, you can put all sorts of photographs on the image as well as a waveform indicator. And in the future, if we decide to go this way, it could actually put the text of what we're saying on the screen. If this works well for us, we could easily, as we talk, because now we're in real time again, we could photograph what we're talking about and put that in real time into this vid version, so that as we speak, you could see the photographs. We could even do vids if we really wanted to, but I don't know, that's a lot of work.
Yeah.
I've been watching it. I put 2 episodes up so far as of this episode. By the time this episode goes out on the feed, there should be quite a few more. I've had to change the bit rate on our podcast to make them more efficient and smaller. So you guys may have noticed that in your downloads of the show. That takes away from the audio quality, but hey, we're not playing music or anything,
right.
So it's not that big a deal.
And then would you be distributing these on YouTube?
Yes.
Okay.
So there's currently 2. At the time of this recording, I have 2 episodes up there, 382 and 381, I think, or 381 and 380. And I'm watching how they're getting downloaded, and a couple times a day,
Sure.
somebody's hitting them. And what's important for us in our distribution of the podcast is now, I don't know if you guys are out there that use YouTube, you know that YouTube is a kind of as you watch a vid, a whole bunch of vids related to that vid through its tags pop up on the side, which means we'll get a lot more exposure to people who may not know anything about our little tiny podcast.
Yep.
Also, if you listen to one episode like all vids, other episodes will show up on the side and automatically go on that playlist because I'm making it as a playlist.
Yeah, I'm always amazed at like my kids like listen to music on YouTube and there's like no video to the music, so there's a lot of audio only applications to YouTube that it's kind of not really intuitive that would work, but apparently it does.
Yeah, and this app also lets us upload to Instagram. So I intend to look at a channel on Instagram of the podcast, and we'll see if that changes things, if we enhance our distribution. If the numbers do go up, then we will up the Headliner membership to be able to do things like vids and photographs and transcriptions and stuff. So watch for that.
Yeah.
In the meantime, we do have a thing of the week this week.
We do.
Now, this thing of the week is one of those things where it's been remixed a bunch of times, and I became aware of this thread of remixes on the latest version, which is actually the drill bit sharpener for the Proxon rotary tool, and that's thing number 4833572 from a user whose handle on Thingiverse is KinBS. Now, that was a remix of what we actually have as our thing of the week this week, because I don't have a Proxon rotary tool. Do you have a Proxon rotary tool?
I don't. I have a Dremel.
I have a Dremel too, and that's why thing number 3059363 that comes to us by who is that? Michael Lovis,
whose name is Daniel Michaelowitz.
he back in 2018 put out a thing that's called the drill bit sharpener with True Leaf Angle, and this one does fit really nicely on a Dremel. And these are for, well, not, you can't put big drill bits in there.
Yeah, this is kind of maybe 1/4 inch, 5/16 tops.
Now, you got to wonder, when you get smaller than that, it doesn't really make sense to sharpen it.
I don't bother to sharpen even 1/4 inch drill bits because they're cheap enough if you buy them in bulk from an industrial supplier. I go through a lot of them in the shop.
Yeah.
But I do resharpen big drill bits, and it is a pain to do so. I've even done them freehand on a pedestal grinder, and you can do that. It just takes skill.
Right?
Whereas this removes some of the skill, but don't kid yourself. There's still a fair amount of skill involved.
Probably. It looks like an easy print, and it threads right onto your Dremel. I'll be giving it a try because that's the actual size of a bunch of bits that I have, and I ruin them pretty quickly.
Well, if you find this an entertaining way to spend your day, by all means, I'll not talk you out of it. But if you actually want to make some holes, go out and buy some new drill bits. Is my advice.
Oh, and that's actually, this thing was a remix from another thing that came out in 2015 called the Drill Bit Sharpener, thing number 1024834, who comes from a Thingiverse user whose handle is MGX.
MGX, yes.
Let me take a look at who MGX
hold on.
really is.
I'll get MGX.
I'm going to beat you to it. Marius Gorgachev. Figures.
You just stepped right into that one. GHEORGHESCU
from Seattle, Washington.
You did a pretty good job on
I
that.
tried. Anyway, awesome designs, all three of them. We appreciate the makers for posting them on Thingiverse. If you've got a tip, a question, or a candidate thing of the week, please don't hesitate. We may not pick it, but send it anyway. Send it to info@3dprintingtoday.com. That's THRE, then the letter D, printingtoday.com. We also invite you to join our Google group, our online forum. Go to Google and type in 3D printing tips and tricks and hit that join button if you want to post. You can also go on our group on Facebook. Just search for 3D Printing Today, number 3 and 3D, in 3 separate words. We try to post all of our show notes on both forums, photographs and comments. We also answer letters there. So, hey, go check it out. We got a show next week, man.
Number 386, you start out giving us an update on the 3D Chameleon.
And then we're going to look at the challenges to belt printing.
And then you give us a look at the See Me CNC Delta Boss.
Oh, boy. Well, I guess that's it.
Great. Thanks for listening.